Hi everyone, hope you had a great first day of intensives. We are in the packet, we're on page 2. Today we're going to be talking about average rate of change. Just a recap of what we've done already. One important thing to know about average rate of change is that you need to understand the formula, which is right over here. Something I also would be highlighting myself. And also to remember that if something is a linear function, it has a constant rate of change. So the problem that we're going to work on today is number 3, which is on the next page. So this one right here. So we'll start reading it. The table shows that the total rainfall in inches from Lancaster for the month of March until April. Find the average rate of change from March to April. What does this answer mean in the context of the situation? B. Does this table appear to represent a linear function, y or y naught? So let's start with the first one. Find the average rate of change from March to April. So if I was underlining, this would be something that's really important right now. Now, if you notice, months, it's not really by names, it's by numbers. So you just have to know that the third month is March and that the 8th month is August. I spelled that wrong. So we're really just looking at these right here. Okay. And to identify our domain and range, our month would be our domain, our x values, and rainfalls are y. Month is part of time, something that we can change. That's why it's our x, and the rainfall depends on the month. So therefore that is our y. So if I just looked at these 2 points and plugs it into the formula, which is delta y over delta x equals y2 minus y1 over x2 minus x1. And I'm just going to plug them in. Again, you can pick any one you want. I'm just going to go with 1.2 minus 4.8 and 8 minus 3. Most important thing is to make sure that these line up, okay? That these are the same as the ones that you have right here. I would put this into my handy dandy calculator, and it will tell me that is negative 0.72. And I can't forget my units, inches per month. Okay, the second part of this question asked, what does this mean in the context of the situation? So if you're looking at this here, this is saying that the average rainfall decreases at 0.72 inches per month. Okay, so now the next question says, does this table appear to represent a linear function? So let's go back to this table and check it out. I'm just going to erase everything that I have on here just so we can check this out for a little bit. So as we're looking at this right now, well, let's see, does this make sense? Well, from 4.8 to 3.2, well, that's decreasing, but then look what happens here. This next month from April to May, it actually increases, then it decreases again, increases again, decreases again. So if I had to think, would this be something that's linear? Remember, a linear function, so that has a constant rate of change. This is not really constant. It's going down, up, down, up, down. We could assume the next one's up, but we can't really be certain. So I would say that no, because the change is not constant. You could also take your calculator and put in 4.8 minus 3.5, and you get a difference of 1.3. Now, if you did 3.5 minus 1.3, you get 2.2. You don't get the 5.1. But let's say if we added a 3.5 plus 1.3, we get 4.8. So we really don't get to this next number. Therefore, again, it's not constant, okay? Have a good day.